Python's immutable strings and their slices. The strings in Python are immutable and support the buffer interface. It could be efficient to return not the new strings, but the buffers pointing to the parts of the old string when using slices or the .split method. However, a new string object is constructed each time. Why? The single reason I see is that it can make garbage collection a bit more difficult. True, in regular situations the memory overhead is linear and isn't noticeable. Copying is fast, and so is allocation. But there is already too much done in Python, so maybe such buffers are worth the effort? Edit. It seems that forming substrings this way would make memory management much more complicated. The case where only 20% of the arbitrary string is used, and we can't deallocate the rest of the string, is a simple example. We can improve the memory allocator, so it would be able to deallocate strings partially, but probably it would be mostly a disprovement. All the standard functions can anyway be emulated with buffer or memory view if memory becomes critical. The code wouldn't be that concise, but one has to give up something in order to get something.
The underlying string representation is null terminated, even though it keeps track of the length, hence you cannot have a string object that references a substring that isn't a suffix. This already limits the usefulness of your proposal since it would add a lot of complications to deal differently with suffices and non-suffices, and giving up with null terminating strings brings other consequences. Allowing to refer to substrings of a string means to complicate a lot garbage collection and string handling. For every string you'd have to keep track how many objects refer to each character, or to each range of indices. This means complicating a lot the struct of string objects and any operation that deals with them, meaning A, probably big, slow down. Add the fact that it's starting with Python 3 strings have 3 different internal representations, and things are going to be too messy to be maintainable. And your proposal probably doesn't give enough benefits to be accepted. Another problem with this kind of optimization is when you want to deallocate big strings. After this operations you have the substring B that prevents a huge string, to be deallocated. Surely you could do copies of small strings, but what if B equals a column 10,000 or another big number? 10,000 characters looks like a big string which ought to use the optimization to avoid copying, but it is preventing to release megabytes of data. The garbage collector would have to keep checking whether it is worth to deallocate a big string object and make copies or not, and all these operations must be as fast as possible, otherwise you end up decreasing time performances. "99% of the times the strings used in the programs are small, max 10K characters, hence copying is really fast, while the optimizations you propose start to become effective with really big strings. For example, take substrings of size 100K from huge texts and are much slower with really small strings, which is the common case, i.e. the case that should be optimized. If you think important, then you are free to propose a PEP, show an implementation and the resultant changes in speed/memory usage of your proposal. If it is really worth the effort, it may be included in a future version of Python.
That's how slices work. Slices always perform a shallow copy, allowing you to do things like. Now it would be possible to make an exception for strings, but is it really worth it? Eric Lippert blogged about his decision not to do that for .NET. I guess his argument is valid for Python as well. See also this question.
If you are worried about memory, in the case of really large strings, use a buffer. Knowing about this allows you for alternatives to string methods such as split. If you want to split a string, but keep the original string object, as you may be needed, you could do. Or, using dot index.
If you want to see more, please consider subscribing.